It's been 2 weeks since we created our alum mixture, and we have some good crystal formation happening. Looks a little bit better than it did last week. I poked some holes into the top of the Kim wipe to allow for better evaporation because it didn't seem like much was happening. And that is one environmental factor that might be affecting the growth of the crystals is the moisture in the air, and if there's enough airflow. If there's too much moisture in the air, then the water will not evaporate as quickly and will not leave behind the crystals. For this video, I calculated the theoretical yield and the percent yield of our alum. And from here you can see that we have to start with a balanced equation. So this is the equation of the overall synthesis of alum, which is balanced. And we needed to know our starting amount of aluminum, which is here. And we started with 1.008 grams of aluminum. And from that, we were able to find how many moles of aluminum based on that gram. And then using stoichiometric coefficients, we were able to relate the moles of aluminum to the moles of the alum, which is 2 to 2. So this factor actually would just cancel out and be 1. And then based on the moles of alum, we are able to find the grams of alum that should be produced based on the molar mass of the alum. And we found that there should be 17.72 grams of theoretical yield for alum based on our starting point of 1.008 grams. For our percent yield, we took our actual yield, which was found to be 17.297 grams of alum, and we compare it with our theoretical yield, and we noticed right away that these values were pretty close, so we were happy with that. And we calculated the percent yield by dividing the actual yield over the theoretical yield and multiplying that by 100, which turned out to be 97.6%, which I think is a pretty good outcome considering there was not a great deal of accuracy in this experiment. And that definitely explains why our experimental yield was not exactly 100%. Our measurements with pipettes and with beakers were not perfect. We had a great deal of error in the experiment. The scales that we used to measure out the starting product or the starting amount of aluminum fluctuated a lot, so we hope that this number is close to the actual value, but it could be off by a few significant figures. So measurement error is definitely a big part of why the percent yield could be off. And then also when we had our final product and we were trying to remove the water to just get the powdery material, there definitely was some issues getting that part right, the drying of the alum, so that could have also affected our percent yield.